and I'm going to present what is Bayesian network and what is Bayes theorem. So first we will talk about what is reasoning. So reasoning means drawing conclusions about a situation based on pre-existing knowledge and facts. And we will also discuss about what is certain and what is uncertain. So certain means if we will take an example that it's raining outside, then it is certain that there must be clouds. And uncertain means if there are cloud outside, then it does not mean that it's raining outside. So that is a uncertain thing. Humans deals with uncertainty daily. We daily deal with uncertainty, just like the example we took earlier. But for the machines, it's really a hard task to deal with uncertain things, because machine understand only zeros and ones. So to teach them what is uncertain things and how to calculate probability of uncertain things and how to predict uncertain things, that is a really bottleneck for them. So uh, in the next slide we have the Bayes theorem. Here the Bayes theorem comes into picture. What Bayes theorem says, it describes the probability of an event based on the knowledge of conditions related to that event. This is the formula that describes the Bayes theorem. So, in general terms, we don't use cause here in the formula. We use as hypothesis. So, if we want to read it, we read it like probability of hypothesis. That is the evidence is true. That's how we read it, and the formula is probability of hypothesis multiplied by probability of evidence. That is the hypothesis is true divided by probability of evidence. Then if we talk about how the it is visualized, how the machine understand and calculate the uncertain things. So they use a directed acyclic graph, a Bayesian network, a belief network. There are three type of things. Here in this video, we are going to talk and understand about a Bayesian network. So how the Bayesian network looks like. So there are multiple nodes, just like I've explained in this diagram, and there are arrows that are directed. It means there is a direction that tells the direction of the nodes, and what is the relation between and dependency between these nodes. So uh, let's move toward the example. This is a really simple example. So here is the example, that is tampering uh, and here there are multiple nodes, and this example is about the fire network, fire alarm network, fire alarm belief network, that is we call like that. This is a Bayesian network, and there are multiple nodes like tampering, alarm, leaving, report, fire, smoke. There are multiple nodes. If we want to see the probability of these nodes, then we have to just click toggle monitoring, and these are the probability of these nodes. So there are multiple probabilities given. There you can see, for example, for tampering node, there is a true and there is a false. So probability of happening tampering is true 0.02, which is 2%, and the probability of tampering not getting it means the probability of tampering is false, that is 98%, that is 0.98. Just like that, there are given multiple probabilities of multiple nodes. For example, if we talk about the leaving node, the probability is true 2% and false 98%, just like that. And if we want to test this Bayesian network, see, this Bayesian network is small now, but in the real time, we deal with multiple things uh, like cause and effect diagrams, and for cause and effects, for example, see crime investigation. So in crime investigation, we use such graphs to identify the cause of the effect. We have a effect, and we want to identify what caused this effect. So in this process, in some techniques we use uh, gates, logic gates. In some techniques, for example, in reliability engineering, we use fishbone diagram, and in the field of AI, we use a Bayesian network to find the cause of the effect. So these are useful in cause and effect drawing, and these are useful in crime investigations. These are used in drawing uncertain probabilities. So calculating uncertain things, these Bayesian networks are also used. So if we want to test this network, so we will click on independent quiz, and then we will click on ask the applet, and then we will click on ask the question. Then we will select the two nodes, for example, tampering and fire. We can see that there is clearly not any dependency between these two nodes. There is a question that is tampering conditionally independent of fire, and we will click on get the answer. Then correct answer is true. Yes, of course, there is not any dependency between these two nodes. Then again we will test this. I will click on alarm and I will click on smoke. And there is again one question: is alarm conditionally independent of smoke? Is alarm conditionally independent of smoke? So let's get the answer false, because there is a common parent between them, that is fire. So that's how you can test multiple times. For example, again we will test it. We will test is living conditionally independent of alarm. uh, get the answer false, because clearly there is a dependency between these two nodes. Just like that, we because see, again I'm saying this is a really small example, so you can clearly identify the dependency. But in the real time, for example, a liver disease diagnosis system, so that diagram became a huge thing. So in that area, you cannot do it manually. You need some tools like this to identify the dependencies. So that's all about it. And that's how you calculate the probabilities of each and every node. And using these probabilities, we can calculate the uncertain things, because at the earlier time, just like we discussed in Bayesian formula, we are using these probabilities and these conditional dependencies to calculate the uncertain probability. So that's the whole thing about this fire alarm belief network, and that I've explained earlier. So thank you very much for listening my presentation.